Another theorem that we get when we are looking at inequalities in triangles is called the Hinge theorem. And this is a theorem that you can actually figure out just by looking at any door because, surprisingly, it uses hinges, and that's where this theorem comes from. The idea is this. Let's say that you have two sides that you know are congruent in a triangle, and that's going to be required. You need two given sides that are going to be congruent from one triangle to the next, and that's why you have these markings on here and here. If you are going to increase the angle formed by those two sides by expanding it this way, it means that the farther side will then also be larger. So you can see how we started with the small side, and as we increased this angle, as we turned this leg wider, we actually made the final side longer as well. And that means that the smaller the angle formed by those two congruent sides, the smaller the opposite side. So here we have then that comparison. The smaller the angle between two congruent sides, which we have two congruent sides, the smaller the opposite side. The larger the angle, the larger the opposite side. And of course you can see this just when you open a door. The further you open it, the two congruent sides there being the wall and the door, the wider the opening you have. And that's called the Hinge theorem, and we use it quite a bit in daily life, and we use it occasionally in math as well. In fact, one of the ways that we use it is quite straightforward. Sometimes we just want to know which side is longer. So when I see a triangle where I know that I have two congruent sides that are forming like this hinge, right? That hinge being that angle, I can tell myself which one is longer by simply looking at this. If this angle is 63 and this angle is 82, the angle E has the larger angle, which means that DF is the longer side. And that's all there is to it. Now, just because, though, we have some that are simple and straightforward doesn't mean that all of them are simple and straightforward. We can actually get a lot more information from this as well. And this is going to bring us into the realm of algebra. So let's look at this problem. We want a possible range for what x could be. And now usually when you see problems like this, you're like, oh, maybe they're similar triangles. Let's fill in everything I can, because if they're similar triangles, I can figure out these two things are equal, it'll be grand, and we'll be done. Well, I have this side is congruent to this side. I know from the reflexive property that BD is congruent to itself. So I now know two sides of these two triangles are congruent. I also know this angle B is not congruent to this angle D. Well, that's not enough information to prove that triangles are similar, but it is enough information for the Hinge theorem. Because if you look at this first triangle, A, B, D, what we have is this situation, where B is 44, and we have two congruent sides. And if I take my second triangle over here, which is that BCD, I can draw that same one next to this, keeping in mind that it has an angle of 35. And from C to D is congruent to A to B, and from D to B is congruent to D to B. So I have this picture now, and what this tells me is, according to Hinge theory, the smaller side will be opposite the smaller angle, which is this angle here at D. So if I take my two listed sides, where the smaller side is 4x minus 8, and the larger side here opposite the 44-degree angle is 2x plus 12, I can then set up an inequality. And my inequality is that 2x plus 12 will have to be larger than 4x minus 8, or greater than. So I can solve that moving firmly into the realm of algebra. And here what I'm going to do is I'm going to get all of the x's on the same side. Remember, you can treat this less than or greater than sign like an equation, like a normal equation, just keeping in mind that if you divide by a negative number, the sign is going to switch. though we rarely divide by negative numbers when we are dealing with geometry. So I'm going to move my x's to the same side, subtracting 2x from both sides, leaving us with 12 is greater than 2x minus 8. Here, I'm going to then try to isolate the x, adding 8 to both sides. This gives me 20 is greater than 2x. And when I divide both sides by 2, I'm dividing by a positive number, so my sign stays the same, and I'm left with 10 is greater than x. So I know that 10 is greater than x, and I would be done at that point. That is it for today. I hope you guys all have a wonderful day.